Hi, MacKenzie.
Hi.
Yeah, you see, you can see everything on my screen, right?
Right.
Good. So, number 8, 9, 10, 11, 12. Which one do you want to do first?
Number 9.
Number
I
9?
tried to do.
Mm-hmm.
I tried to do, but I wasn't getting. I was getting a similar answer, but I was off by a little bit.
Number 9. Right. So sine of x is 4 over 5, and sine of y is that. And they gave you the domain. The x lies within 0 and 90. Y lies between 270, within 270 and 2 pi. And we have to evaluate all those things. Let me write down all those things. Sine x equals to 4 over 5, right?
Yep.
And sine y is
Negative 12 over 13.
negative 12 over 13.
Yes.
Good. And what else we have there? The limit, yeah, x lies within 0 and pi over 2.
0. Yeah. Pi over 2.
That's right, and strictly within that limit. Y lies within, y is bigger than equals to 3 pi over 2. No equality. And strictly less than 2 pi, is it?
Yeah.
Alright, so that is that, and we are supposed to find sine and cosine x plus y. X minus y, right? Plus y. First one is plus y. Alright, so we have to evaluate this value, and let me make sure that you can see everything. Yep. So what we're gonna do, we're gonna use the sum of the angles formula there, and then we utilize the information that we have above right there, right? And we can make sure that the angles, why did they give us those domain values? That's also an important question. So let me write down the formula first. Probably I'll explain to you the limit, the meaning of the limit. So x lies within 0, pi over 2. That means first quadrant, right? That means the angle, the terminating arm is right there, is gonna be in the first quadrant. So that is that. Now the sign is gonna be positive in this quadrant, in the first quadrant, right? So your x is here. That's how it looks like. Make sense to you?
Yes.
Okay, so the y value lies in 270 and 2 pi. This is the second quadrant. I may use different pen if you want. So this is the y value. Now we know that sine in the fourth quadrant negative is going to be negative. Sine in first quadrant is positive, in this quadrant it's negative. That's why we have a negative sign there, right? So that makes sense. And now we solve this thing by using its formula. And let me zoom in there and I write down the formula. Cosine of x plus y is gonna be cos of, do you remember the formulas of the sum?
Yes.
What is that?
It was cos x.
Yep.
X cos y.
Cosine x times by cosine y. Cos x times cos y. Minus, yep.
Sine x.
And sine y, right? So that's the relation that we have for cosine. Now we substitute the values of them, and the values for cosine and sine we already have there, so we just switch the information. Good. So
yes.
All right, now MacKenzie, we have to find cosine x, right? So we have sine x, we don't have the information for the cosine x. So we're going to use the special triangle that we have right now. We know that cosine x is 4 over 5. Cosine of this angle is 4 over 5, and sine is 4 over 5, right? Sine of this angle is 4 over 5. So 4 is going to be opposite, and hypotenuse is 5, because sine x is going to be equal to opposite divided by hypotenuse. So the opposite side is 4, hypotenuse is 5. 4 over 5 is the sine of the angle. Now we don't know what is the adjacent side for x. So the adjacent side for x is gonna be evaluated by finding the base. We're gonna use the Pythagorean theorem. And do you remember what is Pythagorean theorem?
It's a squared plus b squared equals c squared.
Yeah, so you can say that. Now basically Pythagorean theorem, according to Pythagoras, the square of the largest side, which is hypotenuse. Hypotenuse is always the largest side. So the square of largest side equals to the sum of the squares of small sides. So the small sides are 4 and a none. I just call it a, adjacent squared, right? And then I isolate a from that. You're gonna get 25. Move 4 squared to the left hand side. Negative 16 equals to a squared. So that is 9 equals to a squared. So we do square root on both sides. 3 equals to a. So the adjacent side is 3. Good. Now we have all the side lengths, and we can find the cos of the x, right? Because we need it. So cosine, let me write it there. Cosine x equals to adjacent, which is 3 divided by hypotenuse, and that is that. Now I have cosine x, sine x. I have to find sine x, y, and cosine y. And if you go back there, we have the sine y value. Sine y is negative 12 over 13. So negative 13 is gonna be opposite for the y, right? And the opposite for y is this. So negative is due to the direction, because this direction is a negative. We are going in a negative direction. The y value is negative 12, right?
Yes.
Yeah, and the base is 13.
Yes.
Yeah, that means hypotenuse. Let me see it again.
No.
Yeah, that's right. Sine y was negative 12 over 13. So negative 12 is indicating a direction, right, which is right there. Y is going to be negative when you go down. So we went down 12 units. So that's why they call it negative. But the distance is always positive. Distance cannot be negative. Now my motive is to evaluate the adjacent side to the y. And this is the adjacent side to the y. Right?
Right.
So using Pythagorean theorem gives us that hypotenuse square equals to the sum of the squares of the small sides. So the small sides are 12 and we don't know the other side, so let's call it b squared. So square root of 13 is 169, square root of 12 is 144 plus b squared. When you move it over, you can find b. So I do 169 minus 144 equals b squared. That is 69. 125, right? 125 is that. B squared is 125. So you do the square root and you get the value, which is going to be square root of 125 is 15. Now, does it make sense to you, MacKenzie?
Shouldn't it be 5?
Probably I did. Oh man, I did a mistake. That's 25, not 125. I don't know why I did that. And it's not even, yeah. Thank you. So you got that thing actually, that's good. So B is 5 and we go back, write down the B. B is this side length, the blue one, 5, right? Yeah, the hypotenuse is always the largest side, so there's no way that the adjacent be 25, so that was a mistake. So we got it right now. We have all the ratios, and I need cosine of y, so let me write it there. Cosine y equals to adjacent 5 divided by hypotenuse 13. So we got both of them. Good?
Yes.
So now we just substitute them in here. So the first thing is cosine x. Cosine x is 3 over, let me use the black pen for that. Cosine x is 3 over 4 and times by cos y 5 over 13 minus sine x, which was 4 over 5, right, times by sine of y negative, let me use a bracket because that's negative 12 over 13. Good?
Well, I got a similar equation, but I had cos of x be 3 over 5 and cos of y be 1 over 13.
So your cos of x was different from this one?
Yeah, it was 3 over 5.
Cosine x is 3 over 5. Yeah, we also got 3 over 5 there. That's 3 over 5.
Why did you put 3 over 4 in your equation?
Okay, that's a mistake. I don't know why I did do that. Sorry. So that's 5 there, right? I didn't notice that. Probably one of them is then, let me make it show. Cosine x was that 4 over 5, 3 over 5. So let me write it again, 3 over 5. Come on. Five there. And cosine y was the value that we just got, 5 over 13, right?
Right.
Everything else is right? Good?
For the most part, yeah.
So there's no typo in there? I mean, nothing different. So now we cancel this 5 with that 5, and then we 4 over, yeah, now we just times everything and see. We got 3 out of 13, and minus minus is plus, so 4 times by 12 is 48. 5 times by 13, 65. Good. So now we just add them up, and we have to make common denominator. So the common denominator is going to be 65, because we can get 65 on the left fraction by multiplying the numerator and the denominator by 5. So 15 plus 48 over 65. Good. So
Yes.
63 over 65 is the answer of that.
Okay.
Yeah. So that was number 9. Let me make it sure. Yeah, 9A was that. Question number 9A part. And you understand almost everything that we did there?
Yeah.
Good. So now, and the B part is pretty similar. You have to just apply the formula. Do you know the formula for that? MacKenzie, do you know the formula for sine x plus y?
Yeah, we got a trig identity sheet that we're allowed to use on the test.
Alright, so you're going to use almost A, B, C, D. You can do all of them because they involve cosine, sine, and rest of the formulas related to that. But the tangent, the E part and F part, you have to do one extra step. Do you know what is that? In order to find tangent. Let me write it down here, honey. Tangent of x and tangent of y. That's what we need, because we had to find tangent x plus y and tangent x minus y. And I think you already know the formulas of tangent x plus y and x minus y. So
yes.
That's good. But the tangent x, how are we going to figure out the tangent from this information that we had on this sheet? So the two ways, one is you divide sine by cosine, because sine x over cosine x is tangent x, and you can also find it right away from there. Tangent of this angle x is gonna be 4 over 3. 4 is opposite, 3 is adjacent. So opposite divided by adjacent is the tangent.
Okay.
Yeah, there are two ways. You can divide sine by cos, or you can do it explicitly. Both ways it's gonna work. So that is what I was saying. Sine of x over cosine of x is tangent x, and sine of y, cosine of y is the tangent y. And we can use that because we have the information of sine and cosine of xy. So either way, you will find them and then substitute them into the sine formula, like plus formula. Let me write it down. Probably that's enough. Yeah, you can do it there. So the sine, not a sine, sorry, tangent of x plus, or a plus b, is gonna be tangent. Do you remember the formula for tangent a plus b?
Yeah, it's tan A minus tan B
Mm-hmm.
divided by 1 plus tan A times tan B.
Times tan b, right?
Yeah.
And if you have a minus sign there, what is going to happen if we have tan a minus b? What is the
You
mm-hmm.
minus the tops.
Minus on the top and
Plus on the bottom. Or minus on the bottom and plus on the top.
yes. So make it sure for positive. I think for positive we have a positive sign on the top.
Yeah.
Yeah, that's what I was thinking of. But anyways, yeah. So the positive is gonna be on the top and negative on the bottom if you have tangent a plus b. And but if you consider negative sign, tangent a minus b, then this negative is gonna change. The top sign or bottom sign? Negative. Tangent a minus b. What are we gonna get for that? Is everything is positive for negative?
For negative, we minus the top and add the bottom. For positive,
Okay.
we add the top.
Good. It's opposite, right? All right. So that's that. So you have to substitute the information in that equation and you'll be done. Good.
Next question.
Mm-hmm.
Number 10. I tried this again by making a triangle.
Mm-hmm. So
alpha. Doing the work.
So
but I don't think I understood the question.
Say it again, please.
So I tried to find.
Mm-hmm.
Yeah, I just really didn't understand the question.
Okay, let's go together. Alpha and beta are acute angles in quadrant 1. So in the first quadrant, we have the alpha and beta. They gave you the measure of sine alpha and sine beta. Without using calculator, determine the values of sine and tangent of alpha plus beta. So let's write down the values and make a chart for the acute angles. Okay, I go here. I think we can finish it there. So we have angle in the first quadrant, and I make a quadrant Cartesian plane or reference plane. So the first quadrant is this much. This is the first quadrant, right? That zone right there. So I make alpha in a line which is making alpha with the x-axis, and I make a kind of triangle. That's the triangle for the alpha, and sine alpha is 7/25. I write sine alpha there. So 7/25. Beta is cos beta 5/13. Let me make it sure. Yeah, 5/13. Now the beta and the alpha, both of them are acute angle in the first quadrant, so I have to make the beta. Let me use another ink for that. I make another triangle with red color. Now this red angle is the beta.
Yes.
So we have both of the triangles there, and hypothetically we make the drawing of them, And let me write down the cos beta. We know that cos beta, which is right there, is adjacent over hypotenuse. So 5 is adjacent to the beta. Beta is there, so adjacent side is right there. So this tiny side length is 5 from here to there. And adjacent is that one. Sorry, hypotenuse is this one, 13. Adjacent is 5, hypotenuse is 13. So now we have cosine beta, and we can find rest of the ratios. Now we have to go back and see what we are interested in. We are interested in sine and the tangent. So for sine alpha plus beta is going to be sine alpha cosine beta minus cosine alpha sine beta. So we need sine and cosine of alpha beta, and we need the tangent, so we need tangent of all of them. So let's find the cosine of them, and then we find the tangent for rest of them. So I have cosine beta, now I write sine beta. So for finding sine beta, you have to find the opposite side, which is right there, the red side, right? So what we're gonna do, the Pythagorean theorem. So by Pythagoras theorem, we do the square root of the largest side, hypotenuse, equals to the sum of the small sides. One of the side is 5 squared, and another side I have to find, I don't know what is that. So we call it a squared. So this side is a. So 169 is that. 5 squared is 25. Now we move 25 to the left hand side, and it's gonna subtract, and you're gonna get 144, right?
So that would be 12.
Very good. So we do the square root of that, so a is 12. So I write down the value of that there, and the 12 is the length from here to there. Now we write the sine beta value, which is gonna be opposite over hypotenuse. Now we are good with that. We can also find the tangent of that. Let's find the tangent of beta. Tangent of beta is opposite over adjacent. Now we're good with all those ratios. We have sine, cosine, and tangent of beta. Now we're gonna find the cosine of alpha. And for finding cosine and tangent of alpha, we need rest of the side lengths. So we have the sine alpha, which is 7 over 25. Let's go into a black triangle. Sine alpha, and opposite is 7. Adjacent is 25, which is the black side right there, right? And we use triangle, black triangle, use Pythagorean theorem, and find the third side, which is this black side, adjacent side. So we do the same thing, the square root of the hypotenuse, and let's do it here. What we can do up there, we have enough space. So according to the formula, we do, according to the theorem, Pythagorean theorem tells us that square root of the largest side equals to the sum of the squares of small sides. So one of the small side is 7, another we don't know what is that, so let's call it y or b. I call it b. B is this side adjacent to the alpha. So now we squared all of them. 625 is that. 7 squared is 49. B squared. Move it over, and you're gonna get
24.
776. Sorry, what I'm doing. 576. Which is gonna be 24, right?
Yeah.
Alright, so B is 24, which is this black side, and its measure is from here to there. So 24. Now we have adjacent, opposite, and hypotenuse for the black triangle. So we can find rest of the ratios for that. So all we have to find is cosine of the alpha. Cosine alpha is adjacent. Adjacent is 24. 25 is hypotenuse. And the next thing that I need is tangent. Tangent alpha is opposite over adjacent 24. Now MacKenzie, we have all those ratios, and we can find sine of, according to question, we have to find sine of alpha plus beta. So we do.
So
yep.
would I then sub into the equation like I did in question 9?
Yes, now you're gonna substitute the values in this identity or the formula. Sine alpha plus beta equals to this whole thing. So you substitute their values one by one. Sine alpha was given, and that was 7 over 25. So 7 over 25, and cosine beta is 5 over 13, and there is a multiplication within them. Cosine alpha is 24 over, so you can simplify. I just leave it up to you, and 12 over 13. I think you can solve it that one, MacKenzie.
Yeah.
It's easy, right? Yeah. Alright, so now let's find the tangent. Tangent of alpha plus beta, the same thing. You use the formulas. Tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. And the values of tangents are gonna go in, and you solve this thing for the tangent alpha and tangent beta. We have tangent beta and tangent alpha, right? So we have both of them. Good?
Yeah.
All right.
Next question.
Yep, next question.
So I did number 12A okay, but number 12B I got stuck on partway through.
B is cosine of that minus sine of this, and simplify each expression. All right, let's copy that. Cos x plus pi over 3. Yep. So simplify each expression. So we have to simplify this thing, and we already know that how to expand the sum of the cosine, sum of the angles of cosine, and sum of the angles of the sine. Now we use the cos a plus b formula, and according to that, it's gonna be cos of x and cos of pi over 3 minus sine of x and sine of pi over 3. So this is that by using that formula, and minus sine. So for the sine, for this thing, we're gonna solve with the sine formula. So sine of x plus pi over 6 is gonna be sine of x cos of pi over 6 minus, no, plus, cosine x sine pi over 6. Good?
Yeah, I got that.
Alright, now we expand it and substitute the values of them one by one. So the first thing we do is we simply write down the cosine pi over 3. Cosine pi over 3 is 60, and which is 1 over 2.
Yep.
And then we have sine 60 degrees, which is square root of 3 divided by 2. And you can find those measures through the special triangles. And I think you already remember that, how to find the values. We already covered that, right? So by special triangles, you can find sine, cosine of 30, 60, and all that stuff. Good?
Right.
Okay, so next thing is a negative sign. Negative sign is going to change the sign inside the brackets. So cosine pi over 6 is square root of 3 over 2. Sine x stays the same, and negative sign affect this positive sign, negative. Sine 30 degrees is 1 over 2 and times by cos x. So this is the expansion of the whole thing. Now we see that the first term and the last one, they are exactly same, but they differ by sign, so they cancel out. And this one, that one, they add up because they have same signs. So your answer is gonna be minus double whatever you have there. You just double it. And now, since we multiplied by 2, this 2 cancels the bottom 2. So your answer equals to square root of 3 sine of x. Sine of x. That's your answer. Does it make sense, MacKenzie?
So you times it by 2.
Yeah, we doubled it because we have two like terms and they have negative sign. For example, -2, -2, or -4. Negative numbers add up. So whenever you have same expressions and they are negative, you add them. So for positive sign we add, and for both negative sign we also add them. So they had a negative sign here, negative there. So negative things add up. So they double. They were two pieces, so that's why I write 2 there. So 2,
okay.
yeah, so they double. Like, for example, we know that if somebody asks you what is z plus z, so we tell z plus z is 2z. If somebody asks you 3y minus 2y, that's going to be y. So we add or operate the like terms. If they're same, we double them.
Okay.
Good. So that was that. So I hope it's understood.
So the whole answer is just negative
Square root of 3. Yep.
3
Sine
x.
That's right. That's right. So that was that.
Yeah, but what happened to the other sign?
Other terms, like the first one and the last one?
Like I know we got rid of the cosine, but where'd the other sign go? Like we have.
So this sign stays there. This sign that we had in the starting, it stays there. So this sign and that sign, they're still there, right? So in the end, we have these. Yep.
Okay, so yeah.
Yeah, they're staying. So we just substituted the values of these guys. The values of the measures, like the angle was given, right? In this case it was pi over 3, and there we have pi over 6. So we can evaluate the measure of them by the special triangles. You remember the special triangle with pi over like 60 degrees and 30 degrees? So we assume this is 1, that is 2, this is square root of 3. You remember?
Yeah.
Special triangles, yeah. So by special triangle, we can measure all the angles, or you can memorize those angles if you want. That was that.
So next question.
Next is
next one should be number 3 in the next email.
number 30 in the next email. Okay.
3 in the next email.
Okay, so let's check your next email. Actually, you sent me many pictures in the first email, and that is, what was the number, MacKenzie?
Number 3, it says use a double angle formula to rewrite each.
Okay, we got it. So number 3 is saying use a double angle formula to rewrite each trig ratio. So
yeah.
So let's pick the first one, sine 4 theta.
Well, I got number A. It's number B I couldn't get.
Good. So let's do B. Cos 3x. And we're gonna use double angle formula for that. Cos 3x. Right, so we go down here. Cosine of 3x. Alright, so now it's gonna be hard to find a formula for sine 3x, so we use whatever we learned before. We write cos 3x is gonna be cos x plus 2x, because we know that x plus 2x is gonna be 3x, right?
Right.
Now we use the cosine a plus b formula, and the a is x and the b is 2x. So cos a plus b is gonna be cos of first angle multiplied by cos of second minus sine of first angle and sine of the second angle. And now this is that. Next thing is we know that cos x just stays the same, but we can break it down. It's a double angle formula that we can apply on that part, right? Sine 2x and cosine 2x, we can use double triangle formula for that. And if you remember, cosine 2x is gonna be cos squared x minus sine squared x. So in a bracket I write the value of cos 2x, which is minus, and now I write the sine minus sine x, and in a bracket I write down cos 2x and sine 2x. Sine 2x is 1. Let me write down the simple formula. Actually, that's the main formula. Sine 2x equals to 2 sine x cosine x. And what we do now? Now we just open the brackets and simplify this thing. Probably some of them gonna cancel out. Anyways, let's see what happens. Cos x times by cosine squared is gonna be cos cube x, and then this cos multiplied by sine squared, you're gonna get negative cos x sine squared x, and then this guy times there, so we get negative 2. Actually, we have a one term. There is no plus minus, so we simply use the multiplication thing. So we multiply them. So we do sine squared x because we have now two sines, and cos x stays there. Now, they are like terms if you see. So the like terms add up. In both terms, we have sine squared x times by cosine x in both of them. One of them is -1, another is -2. So -1, -2 is -3. And you write either of them in an order. So, which is equals to that.
Okay.
Good. So you understand every single thing? And sorry, I forgot to write cos x. I don't know why. There's a cos x right there.
Oh,
Cos.
For negative sine x, and we open the bracket, how come it becomes 2 sine squared x cos x, and there's no sine x with the cos?
Here you mean, or there?
Like negative sine x, you put an arrow, and it goes to 2 sine x.
But there is no sign. But there is, we don't have any positive, negative right there. We don't have any sign. So sine just times with the whole thing, and the whole setting inside the term, we have just a one term. And there we had two terms. These were two different terms. But right now we have just a one term, and sine x times by sine x, and you get sine squared x. And the cosine stays, and cosine stays the same. 2 goes at the front. And good. So does it make sense now? This -2 and -1, they're like and they add up. So that is your answer for that question. I hope you understand that.
Yes, I do.
Good.
Next question. Number 12.
Number 12 on the same sheet. And we have to go back to the previous one. I'm in the next one. Alright, so that was second. Now I go to this one. Number 12. Yeah, there.
It says use the appropriate compound. Angle formula, and that one.
Appropriate compound, angle formula, and double angle formula to develop a formula for sine 3 theta in terms of cos and sine. So that's the same stuff that we were doing. We did for cosine 3 theta in the previous question. Now we do for sine 3 theta in terms of cos and sine. So let's start by sine 3 theta. Sine 3 theta. Sine of 3 theta. Now we can break down the 3 theta term. So 3 theta term is going to be equal to theta plus 2 theta. And good. Now MacKenzie, we do sine A plus B, which is going to give you sine of the first angle times by cosine of second plus sine of plus cosine of the first angle times by sine of the second angle. Now double angle formula we're gonna apply here and then there. And we need the answer in terms of sine and cosine, so we will be using the standard double angle formulas. So sine theta goes there, and cosine 2 theta equals to cosine squared theta minus sine squared theta plus cos theta. And double angle sine is gonna be 2 sine theta times by cos theta. So we close the bracket right there. Now the next thing is we times all those terms one by one. The first terms multiply here and then it goes there. So we get sine theta times by cos squared theta. Negative sign stays within both of them. And then sine theta times by sine squared is going to be sine cube theta. So next thing is cos theta times by that whole, this is just a one term. So you get plus 2 sine theta cos squared theta. So you're going to get a square of cosine because we have two cosines there, right? This one and that one. And this is a whole one term. So we multiply this whole thing with the cos. And now we got this thing. And let's see if we have something common. Yes, we have like terms. This term is like, they're alike, right? The first and the last, because they have the same variables. So Mac, what are we gonna do in this case? We triple.
Combine them?
Yeah, we triple them. Cos squared theta minus sine cube theta. So that's your answer. Here we go. Right, so any doubt, any question regarding that one?
I think I get it now. And then the rest are almost the same.
Yeah, rest of them are same. Probably we were doing tangent 3 theta. Yeah, it's the same process. You break it down and then redo the thing. This time you have to do in terms of tangent, basically. Tangent 3 theta in terms of tangent theta. Let's do that one. Probably it's gonna take, I'm gonna do this one very quickly. Tangent 3 theta. So tangent 3 theta is tangent of theta plus 2 theta, right? And tangent 2 theta. Now let's apply the formula for tangent a plus b, which is going to give you tangent theta plus tangent 2 theta divided by 1 minus tangent theta and tangent 2 theta times by tangent 2 theta. So there's time. Tangent theta plus tangent 2 theta and over 1 minus the multiplication of those things. Right?
How do you get the denominator tan times 2 theta?
Denominator is always like that. Like in a plus b, tangent a plus b if you do. What is the formula for tangent a plus b?
A plus b?
Yes.
Or tan 2x?
Tan a plus b.
A plus is tan a plus tan b 1 minus tan a times tan b. So, okay, I see where you got it.
Yep. So this is the formula that I'm using right now. The tangent, the bottom one, you see that? This formula. So tangent A plus B is tangent A plus B over 1 minus tangent A tangent B. So by the same formula that we have there, I got this thing, and now I'm gonna now I'm gonna do the same thing. I'm gonna repeat the same thing. Let me do it here in this section. I'm gonna go back to this equation later on. Probably I'm gonna do it here. Now tangent of 2 theta, what is that? Basically you're gonna use the same formula. Tangent 2 theta equals tangent theta plus theta. So therefore, by the same formula that we are doing right here on the left hand side, we can do tangent of first angle plus tangent of second angle divided by 1 minus tangent of the first time by tangent of the second angle. And now we do simplify that. The top is numerator is double now because they're same. 2 tangent theta divided by 1 minus tangent squared theta. So yeah, so we're gonna replace this thing by that, and this is gonna be go substitute right there. So now I go back and I substitute the value of tangent 2 theta on both places. I write tangent theta plus tangent double angle is going to be 2 tangent theta divided by 1 minus tangent squared theta, right? And the bottom part, 1 minus this thing stays the same. Let me write equal sign in the middle. 1 minus tangent theta times by tangent 2 theta, which is 2 tangent theta divided by 1 minus tangent squared theta. So now next thing is we next step is we just do the simplification. And if you remember, let me write down this relation. Secant squared theta. Secant is basically 1 over cos squared theta. And if you do minus 1, it's going to turn into, if you do the LCM, 1 minus cosine squared is sine squared theta over cosine squared theta. So we know that 1 over secant squared minus 1 is tangent. But the answer should be in tangent, so I was thinking of it's a different formula. The formula is basically, we don't have to use it, but I can mention it for future. So this is secant squared theta minus 1 is tangent squared theta. This is the identity that we did when we were doing the basic stuff, but we don't have to use this one because this situation is not rising right there. So we have 1 minus tangent, not a 1 plus tangent. So we do the cross multiplication and cancel out the things which are necessarily. Alright, so let's do the top part. I do divided by 1. So in order to make the same numerator and denominator, multiply this guy by this bottom, right?
Right.
So I don't want to make mess, so let me erase that part. And now we get tangent theta times by 1 minus tangent squared theta divided by 1 minus tangent squared theta plus 2 tangent theta over 1 minus tangent squared theta. And now the bottom part also, we're gonna do the same thing at the numerator place. So we do divide this 1 by 1 And we do the same thing, and what we're gonna get? We get 1 minus tangent squared theta divided by 1 minus tangent squared theta minus tangent theta to tangent theta, which is 2 tangent squared theta divided by 1 minus tangent squared theta. So this is what we got. Now the next thing is, let me write the equal sign in the middle. This is the whole term. Now we can multiply them this times by this whole bracket. Tangent theta minus tangent cube theta. Then we do plus 2 tangent theta. And the bottom is same, which is 1 minus tangent squared theta. The whole thing is going to divided by that thing, which is going to be, the base is 1 minus tangent squared theta, and the top is going to be 1 minus tangent squared theta minus 2 tangent squared theta. So we got that, and now we have a fraction. This is a whole fraction, top part, divided by a fraction. So what we're going to do, we flip them and cancel the top and bottom, or simply you can cancel it there. So you cancel them and we get the top part divided by this one. So top part have a 2 tangents, 2 like terms. Tangent theta and 2 tangent theta are like terms, so we add them up. So I write 3 tangent theta minus tangent cube theta divided by 1 minus tangent squared theta. If you notice, the bottom part is also having 2 like terms, so we get negative 3 tangent squared theta, right? This term and that one, they're like. So if they're like terms, if they're alike, you add them. So we got this thing. So there we go. That's your answer. That was pretty long though.
Yeah, that's okay.
Okay. Yeah, that's this big. MacKenzie, do you understand this whole thing?
What was the final answer again?
So the final answer is 3 tangent theta minus tangent cube theta divided by 1 minus 3 tangent squared theta.
Okay. Yeah.
Good. So that is that. And when did we start?
We start around 9, so I think we're pretty much done now.
Oh, right, hon. So yeah, that was that, and go through that stuff. And do you have anything urgent that you just want to know now?
Pardon?
Do you have anything urgent that you want to go over quickly? Anything?
There's just this one thing. If it it's really quick, probably.
Mm-hmm.
Number 9.
Number 9.
Yeah, it would be it's prove each identity. So
Yeah, prove cos squared theta minus sine squared theta. So prove each identity, and sorry. Yeah, those are the identities. Didn't we do that stuff before? That's pretty basic though. So which one do you think it's hard, or you don't know? So you have to number A part?
Yeah.
So the top part, if you notice that this is a cosine 2 theta, right? The top part is cosine 2 theta, and at the bottom you can take cos 2, or just simply do the differences of squares. You don't have to overcomplicate it. The top is 2 differences squares, so it's the differences of squares, and you're gonna use the formula for differences of the squares. So you do cos theta minus sine theta bracket, and the next bracket is gonna be cos theta plus sine theta. The bottom part, you take cos theta out, and when you factor out cos theta, you're gonna get at the bottom cos theta plus sine theta. Let me do it quickly.
Yeah, I got the top part. The bottom part was messing me up a little.
Okay, let's go. So the top part is cos theta or AB. What they use? They use XY, right? No, theta. They're using theta. Sorry. So you do cos theta plus sine theta bracket times by cos theta minus sine theta divided by, so at the bottom, MacKenzie, you see we have cos theta common, so you factor out cos theta, you're left with, inside you're gonna left with cos theta minus sine, no, plus sine, yeah, plus sine theta, so plus sine of theta. This is what we got, and they are same, so they cancel out. So we got cos divided by cos theta divided by cos theta minus sine theta divided by cos theta, sine theta divided by cos theta. So we got cotangent, not cotangent, sorry, they cancel, so we got a 1 minus tangent of the theta, which is right side. So the left side was that one, and this one was the left side. Right? MacKenzie. So that was for today. I'll see you tomorrow then. Have a good day. So this was London Math Illusions work that I did. I made a video with my student MacKenzie, and if you have any question, just ask me. Go to londonmathsolution.ca or just Google London Math Solutions. You're gonna find all the links like Facebook and my contact number and everything. Thank you so much. Have a good day.